Okay, so the first thing we're going to do is we're going to just see where we're at. Remember what this command does? It's the list command. So it gave us a few basic workspaces. When you're going to write ROS, you got to have a workspace for it. So we're going to navigate into the ROS2 workspace for no particular reason. That's just the one that we're choosing. We're going to CD to ROS2 workspace. And you should see in your command line prompt that we are now there. All right. And then from there, if we do ls, we should see these four directories. We have build, install, log, and source. Source is where all of our code is going to end up. So we're going to go cd to source. All right, cool. So now in source, if we list, there should be nothing here. This is where we're going to put all of our stuff that we're going to make today. So we are first going to create a package. Liam, do you want to explain what a package is?
Yeah, basically, packages are at the build level, the atomic unit. So pretty much when you build any ROS2 code, it does it at the package level. So everything in a package gets built together. I'm not sure exactly how we're doing it this year, but for example, you can have a package for all the code that runs on the robot, all the code that runs on the deck. That all compiles and runs separately. But yeah, really not too much to say about it. It's mostly an organizational thing. You won't be worrying about that. So, but yeah, that's essentially what it acts as.
Yeah, so it's basically a way to separate different parts of our robot, like folders, basically. So you could have like a controller, you could have the robot, just any different components of your robot could go in different packages, or they can go in all in the same thing, depending on how organized and modular you want to get. So we need to create a package. So we're going to do that using ROS2. This is specifies we're going to use the ROS2 commands. And then we're going to do PKG, standing for package, and then create. And then we need to tell it what we are going to create our package in. So we're going to do --build under -type. And then it's going to be in Python. So if you're using C++, you would do ament CPP, I'm pretty sure. But since we're going to be using Python, we're going to do ament, AMENT _ Python. And if you don't want to type this out, it's obviously right here. And then we got to specify dependencies. So packages will be dependent on each other. So all of our packages are going to be dependent on RCLPy. And RCLPy is like the Python module library for ROS stuff. So we're going to be using that like crazy. So yeah, we need.
I think it stands for ROS Client Library, something like that.
Something like that.
That's totally, yeah. I think that's what it is.
So -- dependencies. I'm hoping I'm spelling this right. If not, I'm going to just retype it. And then RCLPY. P. And then enter. What did I do? I probably typed something wrong. So I'm going to just copy it and paste it. There it is. Okay. So if you type everything correctly, you should get something that looks like this. It tells us what it's creating. It tells us we have dependencies. It's telling us our build type. If we wanted to put descriptions, maintainers, licenses, all that stuff, there's a file for that. So it's just giving us a summary of everything that happens.
Again, this is not going to be something you should be worrying about.
Yeah, we just got to set this up for today.
Yeah.
All right, cool. Everybody good?
What's up?
What's up?
If I'm more versed in C++ and I'm using ament CPP, is it the same type of
just use Python.
just Python?
Yeah, for today, because we did not learn the C++.
Probably the
stuff.
majority of the code is going to be in Python.
Yeah.
Okay.
But yeah, Python's easy.
You end up having to make a list file, and if you want a package with both Python and you can no longer do what they're now showing you.
Yeah. If you want to play around with it on your own time, that's okay. But all the sample code and stuff we have written is in Python. I don't know what it would look like in C++.
I don't know. I'm sure it'll be very similar, but you got to go look up what's the C++ equivalent function, what's the C++ equivalent package.
Probably pretty similar.
Yeah, I'd say it's pretty similar. But now we're going to build. This is how we're going to basically compile our stuff. It's going to take a second. It's going to search, and then you should get something that says standard error output. That's normal.
Yeah.
All right, everybody good? Did you build your package? Did you build the package?
Yes, we're here.
All right, cool. I'm gonna assume that's yes. So if we look at off-brand VS Code, we should be able to see within our ROS2 workspace.
Wait, can you put each of these separate?
Each of what?
Each of these.
Probably. I
Oh,
don't.
I'll see that later.
Yeah, that's.
You do that
And then
later.
you'll go in source, and then you should see something that looks like this. So you'll have the package that we created, which is called hello. And then you also have build, install, and log. So within hello, you'll have another thing called hello. And in that, you'll have underscore, underscore, and init. And then you'll also have a few other files that are kind of relevant. So package.xml is going to define the name of the package. It has license stuff. So if you ever want to publish this, that's where you'd put all this. So if you wanted to put your email, you could put that here. A description of the package would go here. It also lists our dependencies. So we'll be messing with those later more. And if you want to put version numbers, the package name, all that, basically just information about the package goes in package.xml. All right, then we also have setup.cfg. Do not touch that. Do not touch this. We will not be touching that. And then we also have setup.py, which we're going to do some stuff with later. It's going to basically just set up our package and get it ready to actually run what we need it to. And then finally, we have a init.py, which is basically the standard Python file that it creates for us, but we're going to create our own. So any questions on anything that's happened so far? All right, cool. Well, you guys have successfully created your first package and probably the only one you'll create while you're on the team, because we only are probably gonna have one or two. We'll figure that out.